Welcome back to our next lesson. We are still looking at momentum as a topic. So there is a lesson that I've done which you can able to access in our website, innerlandnetwork.com. You can able to access all the resources that you need about momentum. But then now here I'm just giving extra work, maybe to help you understand what momentum is. So let's start. So I have some questions here which will be able to help us understand how momentum relates to the resultant force. Should you have any challenge of maybe the definition of momentum, please check in our website, or you can able to check from the previous work that we have done. But then maybe before we look at these questions, maybe we need to understand maybe how they relate, how momentum relates to the resultant force in terms of the equation. So I think that is what we can able to start with. So from definition of momentum, so we know very well that momentum is given by mass times velocity, meaning that, so assuming that a body is moving from one particular point to another and there is a change of velocity. So if initially, the initial velocity, we call it u, so a body is moving to maybe a particular point and then velocity changes from u to v. That means there will be time taken for this to happen. So if you want to change in momentum, so change in momentum will be the final momentum, I can call it pf, minus the initial momentum, I can call it pi. But then how do we find the initial momentum and final momentum? So initial momentum, let me call it pi, will be given by mass times initial velocity. The mass is not changing for this case. Then final momentum, I'll call it pf, which is mv. So mass times the final velocity, meaning that if I need change in momentum, that will be mv minus mu. So that is unavoidable. All right. So change in momentum. Next time we'll talk about thunder and lightning in our lesson and electric charge. Anyway, let's continue. So change momentum is mv minus mu. So meaning that if I need the rate of change in momentum, so the rate of change in momentum, so the rate of change in momentum, that will be delta p over the time that is taken for that matter. So that means I will be able to have mv minus mu divided by the time taken for the body to change its speed from u to v for that particular time. So if we factor out m, we'll be able to find v minus u over t. So this is under motion. V minus u over t, that is actually acceleration. So we're able to realize that the rate of change in momentum is given by mass times acceleration. But then if you remember clearly from our previous lesson, which you can still refer from the website, we know that mass times acceleration, this is from Newton's second law of motion, which will give us the resultant force. So it therefore means that if ma is equal to mv minus mu over t, yet mv minus mu over t is the resultant, is the rate of change of momentum. Therefore, resultant force is given by mv minus mu over time taken. Later on in A level, you will realize that this is the definition of force. I know right now we are still using definition of resultant force. Right now we are still using for the push or a pull. Anyway, no problem for that. But this is actually the definition of a force, just in case you are asked. So this is how force relates to momentum, and to be specific change in momentum. If I multiply both sides by t, I multiply this side by t, I will have force times time, which is equal to mv minus mu. And then you can able to see clearly this force times time is called impulse, which is equal to mv minus mu. So from here, it means impulse has two definitions. So the first definition is that impulse is defined as a product of force and time. So if a force acts on an object, so for how long does it take the force to act on the object, like the time of impact? Yes. So, or we can define impulse as the change in momentum. So from here, if we use force times time, we prefer to use unit of force is Newton, unit of time is second, meaning that the unit of impulse is Newton second. But you can also see here, the unit of change in momentum is kilogram meters per second. So meaning that impulse we can use the two units. And even for momentum, if you talk about change in momentum, we can use ns. So ns is equal to kilogram meters per second, as long as we're talking about the change in momentum. All right, so without wasting time, let's look at a few questions that I've gathered here to help us understand that relationship between resultant force and momentum. And now that we've introduced another term, impulse. For more examples and explanation, please refer to what we have covered before. Anyway, so question number one, a moving object undergoes a change of momentum. What is the unit for change of momentum? So they're very smart. The moment they ask you unit of change of momentum, there is no way they can put for you here kilogram meters per second, because the same thing. So ideally, so that is C, it is still in our memory. Which statement describes the impulse acting on an object? The impulse acting on an object. So we already know impulse is defined in two ways, either as the change in momentum or as the product of force and time of impact. So impulse the change in kinetic energy? No. Impulse the change in momentum of an object? Impulse is the rate of change of force acting on an object? No. Impulse is the rate of change of momentum. The rate of change of momentum is force. That means our answer is B. Alright, number 3. A constant force acts on a body, causing the momentum of a body to increase. Which expression relates the force to the momentum and the time taken? So you can able to see that this is A. It's just if you refer to what we have actually covered here. So force is change momentum divided by the time taken. Number 4, a gas molecule strikes the wall of a container. The molecules rebound with the same speed. So this is the initial, and then it goes. When you see a question like this, be very careful. So if, let's say, the body is moving with a speed of v, when it rebounds, and the speed, you see, it is rebounding with the same speed. But you see now, because you're talking about velocity, speed is just the magnitude of the velocity. That means the direction of this velocity will change, so it will be negative v. Yeah, so be careful. What happens to the kinetic energy and what happens to the momentum of the molecules? Kinetic energy, or I can use EK. Kinetic energy is given by a half mv squared. So kinetic energy is a scalar quantity, where this v means speed, not velocity. But when we talk about momentum is mv, where this v here means velocity, not speed. So velocity is a vector quantity, while speed is a scalar quantity. So the one that is going to change here is momentum. Kinetic energy will remain the same. So kinetic energy stays the same while momentum changes. Why? Because kinetic energy, if mass is the same, so it means the v is the one that is changing. So I hope that is clear. If you have any question, you can always ask in the comment. Alright, number 5. A ball falls vertically to the floor and rebounds vertically upwards. So this is you can always refer to this paper here. So just before it hits the floor, its speed is 4.0 meters per second. So that means it's going down. So just before it hits, that is 4.0 meters per second. Okay. So as it rebounds, its speed is, so as it rebounds, that means as it's going up, its speed is at 3.0 meters per second. Okay, the mass of the ball is that. What is the change in momentum of the ball? So here also you must be very careful of the direction of momentum. So if you decide that moving downwards it's a negative, that means when it goes upward it will be positive. So we can try this, but then for you, you try make 4 to be positive and make 3 to be negative, and then confirm what you're going to talk about. So here, what is the change in momentum of the ball? So change in momentum is equal to mv minus mu. In other words, I can just have m into v minus u. So this, I will just have it here. So change in momentum will be m. M is 0.5, which is like a half, 0.5. And then, so the final velocity here will be positive 3 minus negative 4. So that's going to be 0.5 times, inside here will give us 7. So 0.5 times 7 will give us 3.5. So we want to know the direction of the change in momentum. Now, the answer we're getting here is positive. And if you get an answer which is positive, what does it mean? You check your direction. So remember, downwards I took to be negative, upward I took to be positive. And if my final answer is positive, then it means that it's going upward. So the answer is D. I hope it makes sense. There's another concept testing that. Number 6, a moving ball with a momentum of 25 kilogram meters per second collides head-on with a wall, as you can able to see. The reference you can able to check there. So it rebounds from the wall with the same speed but in opposite direction. So if I take this to be negative, then I will take this to be positive when it rebounds. Or for this we can try the other way around. So let me take initially, I can decide that, you're the one decided. So I can decide that as it moves to the right, you can make it positive. And then as you go to the left, you make it negative. But then just understand the sign, that your sign, if you say positive, it means positive to the right. If you say negative, it means to the left, because you need that for your final answer. But then sometimes the negative, positive doesn't matter as long as you understand where to insert them. It rebounds from the ball. Sorry, it rebounds from the wall with the same speed. But what is the average force exerted on the wall by the ball during the collision? So the force is given by change in momentum, that is mv minus mu over time taken, and I can say m into v minus u over t. All right, so here the mass is 25 kilogram, and it is moving, so 25 kilogram meters per second. Oh, that is the momentum. That is the momentum. We already have momentum, so it's always good to understand these things. All right, so that is our momentum. That is our momentum. So that is already, so it is moving with the 25. 25. So if we take 25 to be positive, that means when it goes back, it will be negative 25. That means we'll be able to have negative 25 minus the initial one, which is 25, divided by the time taken, which is 50. M here means milliseconds. So that is 50 over 1,000. So if you have challenge about prefixes, there is we've done that topic. You can always refer. So this will be 0.005. 0.05. So that will be minus 50 divided by 0.05. So I don't want to I don't want to guess. So that will give us what? That will give us 50 50 divided by 0.05, that is 1,000. That will give us 1,000. 1,000 newtons. All right, there's a structured question here. So this is a structured. Number 7, figure 2.1 shows a hammer being used to drive a nail into a piece of wood. The reference of this question, you can able to see from there. You can able to see the hammer and its, the way it is driving. So the mass of the hammerhead is 0.15 kilogram. The speed of the hammerhead when it hits the nail is 8.0 meters per second. So the time for which the hammerhead is in contact with the nail is 0.0015 seconds. The hammerhead stops after hitting the nail. Pop, pop, pop. So that time is very short because that is the time of contact. Pop, pop. Okay. So calculate the change in momentum of the hammerhead. So the change in momentum here, so we have momentum which is going by mv minus mu. So either the final or the initial velocity is 0. So that means the change in velocity is just 8. So we just take mass, which is 0.15. 0.15 times 0.15 times 8. So 0.15 times 8, that will give us, we consult our calculator here. I have refused to think. Okay, so 0.1815 times 8, that will give us 1.2. 1.2. Then the other question is that set the impulse given to the nail. So impulse is equal to the change in momentum. So that means we'll have 1.2. That is Newton seconds. This should be kilogram meters per second. Calculate the average force between the hammer and the nail. So force is given by change in momentum divided by time. Change in momentum, or we can say, because we have part B, which is impulse, so we know that impulse is force times time. That means that force will be equal to impulse divided by time, so which is 1.2 divided by time, and time is 0.0015. And once again, we consult our calculator. So the calculator, so that is 1.2 divided by, 1.2 divided by 0.0015, that gives us 800. That gives us 800 newtons. 800 newtons. So that is all some of the questions that I gathered together to help you understand the relationship between resultant force and change in momentum, or the relationship between resultant force and impulse, or the relationship between impulse and change in momentum. Until next time, stay tuned. You can able to share this video to help someone if you cannot subscribe. Anyway, that is all for now. So in our next lesson, we will look at not lesson, because we have done already lessons. So in our next video, we'll look at the conservation, the law of conservation of momentum.